So let's start by having a look at a couple of equations and in vertex form, and it asks us to solve them. So remember, to solve them, this means to find the solutions. And we know, we could say aka, also known as our x-intercepts, our roots, or our zeros, right? All those words mean the same thing. So if we're trying to find our solutions, what are x-intercepts, then we need to solve for x by subbing in y equals 0. So if y is 0, we're going to use algebra to isolate x. So I'm going to add 16 to both sides. Okay, and then we'll take the square root to get rid of that power of 2. And remember, when we take the square root, it's going to result in the negative and positive version of whatever the square root is, which is 4. So plus or minus 4 equals x minus 4. And then we've now created those two equations. So x minus 4 equals positive 4, and x minus 4 equals negative 4. So we could say x equals 8, or x equals 0 when we add 4 to both sides. Those would be our solutions. Okay, well, let's take a look at another one. So again, we're going to sub 0 in for y. And we're going to isolate x. So I'm going to bring the 9 over by subtracting it. And then we'll take the square root of both sides. Okay, when you try to take the square root of both sides, you should get an error in your calculator. So you can't square root a negative number. Okay, so we could say, therefore, there are no solutions. And if we did a rough sketch of what's happening here, we can see, because this is in vertex form, that my vertex is at -3 and 9. Right, so my parabola is going to look something like that. Because my a value is positive, our vertex is at -3 and 9. So that proves to us that we don't have any solutions. It never crosses our x-axis. So it kind of makes sense that we got to that point when we tried to solve it, that there are no solutions. It doesn't cross the x-axis. When we're in vertex form, we know how to find the vertex. So let's just remind ourselves how to do that. And then when we're in different forms, how do we go about finding that vertex? So this first example, we're in vertex form. So we can see that the vertex is at 3, 7, right? Because it's the h value is always going to be the opposite. Well, the next example here, we're in factored form. So we're first going to have to find our zeros. We're going to have a 0 x equals 0 and a 0 at x equals 10. So we're going to use those zeros to find the midpoint. So that'll be the x value of our vertex. Will be 0 plus 10 divided by 2. So the x value of our vertex is at 5. Okay, once we have the x value of our vertex, we'll sub in to find the y value of our vertex. So y value of our vertex is going to be at 5 times 5 minus 10. So the y value of our vertex is going to be at 5 times -5, which is -25. So now that we found the x and the y value of our vertex, we could say that our vertex is at 5, -25. And we know that process. And finally, if we were in standard form, how do we go about finding that vertex? Well, we'd have to factor it first and then go back through the process we did on that previous example. So if we factor, we need two numbers that add to a -2 but multiply to a -8. So those two numbers is going to be a -4 and a +2. So we'll have what y equals x minus 4 and x plus 2. Pause the video for a minute and then go through the process of identifying your zeros and then your axis of symmetry and your y value of your vertex to find the vertex for this one. Okay, so as you work through finding your zeros, your midpoint, and eventually your vertex, you should have found that your vertex was at 1, -9. So those are our three different forms of our quadratic, and let's just label them. We have vertex form, we have factored form, and we have standard form. In all three forms, we should know how to find our vertex because it's one of the key points on our parabola. We're going to take a look at now, when we're in standard form, is there a faster way to get my vertex than to have to go through factored form first and go through all that process of finding my zeros, finding my midpoint, finding the y value of my vertex? So if we take a look at standard form and we think about getting it into factored form, we're going to kind of start to look at how does this look similar to our vertex form, and maybe there's a shortcut. So with this first one, we have y equals x squared plus 6x plus 9. Now, this is a very specific type of trinomial that we skipped when we went through our factoring unit. So we're going to talk a little bit about it now. This is what we call a perfect square trinomial. And we skipped this method during factoring, but it's an important one to use if we're going to complete this square. What a perfect square trinomial is it means that we can, we're able to square root our first term and square root our last term, or our third term. Okay? So the square root of our first term goes in brackets, and then the square root of our third term goes in a set of brackets. They go in the same bracket, and then the sign in the middle comes from our middle term, or from our bx term, and then it's just to a power of 2. So I'm going to show you what I mean by this, because that was a really quick version of explaining the perfect square trinomial. So I can identify if I have a perfect square trinomial because I can look at, can I square root the first term and can I square root the third term? Notice that this is different than a difference of squares because a difference of squares is only 2 terms. So I can square root my first term, it's x. I can square root my last term, it's 3. So to factor this, what we're going to do is we're going to stick x at the front, we're going to stick 3 at the back, and the sign on my bx, or my middle term, is going to go here. So since it's a plus, it's going to become a plus. Okay, and then we just square it. Because if we were to factor this, this would be x plus 3 times x plus 3, which we can just write as x plus 3 squared. Okay, so that's how we factor a perfect square trinomial, and we'll keep looking at these in this part of the unit. So now that we have it as x plus 3 squared, well, I can see that I have it in factored form, but it also looks very similar to my vertex form. Right? I could just put a plus 0 on here and it would look exactly like my vertex form. So we could say that this here, this perfect square trinomial, this is both factored and vertex form. We can see we have an x-intercept at x equals -3. Okay, and our vertex would be at -3, 0. Right, because if we look at what our x-intercept is by looking at it as if it was in factored form, it would be -3. And our vertex, if we're kind of looking at it as if it's in vertex form, would be at -3, 0. Okay, so let's see if we can look at another one and identify if it's if we can get it to a form that looks both like factored and vertex. So this next one is obviously going to be a perfect square trinomial again. That's the point of showing these examples. So if I square root x squared, I have x. If I square root 16, I have 4. So that means in factored or vertex form, I'm going to have x, I'm going to have 4, and the sign on my b term is going to go between them. And then I'm going to raise that to a power of 2. So again, you can see this could be considered factored or vertex form. We could identify our vertex as 4, 0. So if we had an example that we wanted to get it into the form where it looks like vertex form and it looks like factored form, there's a process called completing the square that we can do this with. So sometimes we might not be given a perfect square trinomial, but we can make it into a perfect square trinomial by maybe adding or subtracting a value. So for this next example, I want to change this plus here to a minus. So this should be x squared minus 10x. If we look at how we would factor that, I want to create it so it's a perfect square trinomial. So what that means is I want to be able to square root my first term and square root my last term. So if you look at our previous examples that were perfect square trinomials, there is some pattern you can see between the number that was square rooted and our middle term. So you can see in this first example, we square rooted 9 and we got 3. Well, our middle term is also related to 3. You can see that it's 2 times whatever that square root was. And the same is true here, right? We had 16 and we square rooted, got 4. You can see that our middle term, our 8x, is twice whatever 4 was. So if we work backwards with this other example, we can see that we have a middle term of 10. Oops. We have a middle term of 10. So we should be thinking, okay, what number can I double to get 10? Okay, and we should be thinking, oh, well, I could double 5, and that would get me 10. So that means if I was to take the square root of 25, that would get me to 5. So if I wanted to square root a number, I'm going to square root 25, and I'm going to square root x squared. Keep in mind here, though, that if we decide we're going to add 25 to an equation, we also need to subtract 25 from an equation, because that's really just saying, like, I'm going to add 0. If I add a number and then subtract it, that doesn't actually change your equation at all. It just kind of extends the existing equation. So by adding and subtracting 25, I've created this perfect square trinomial. Okay, so we'll have something that looks like that, x squared minus 10x plus 25 minus 25. Well, now I know I can factor those first 3 terms. So the square root of x squared was x, the square root of 25 is 5, and I know the sign from the middle goes between those two. So I'll have x minus 5 squared, and then I still have this minus 25 that's going to go on the outside of my brackets. Okay, so we need to make sure we add and subtract that same number. So now we can see that we're in vertex form. This looks a little bit different than our normal factored form, and we can say that our vertex is at 5, negative 25. And if you have a look, this is the same as this example we did up here when we were in factored form. But instead of just leaving it in factored form, we got it into vertex form. So this process of completing the square has a few steps that we're going to take a look at in order to know how can we just go from standard form to vertex form. So find the vertex by completing the square. So the first thing we're going to do is we're going to use those first 2 terms to create a perfect square. So let's underline this. So we're going to use the first 2 terms to create a perfect square trinomial. Okay, so I'm going to think about them. I'm going to bracket them. I'm going to think they're kind of their own equation. So remember, we had to think of some number that was half of 6, and then we could square root. It was the square root of a number. So something that would be half of 6 would be 3. Well, what can we square root that equals 3? we should see that it's going to be 9. So we're going to add 9 and we're going to subtract 9 to the equation to make sure we're keeping it balanced. Okay, so now we know we've created this perfect square trinomial with those first 3 terms, and we can factor it. Right, I'm going to take the square root of x squared, and I'm going to take the square root of that 9. So that'll be x, and the square root of 9 is 3. And then I'll bring down that sign from my middle term. So I'll have x plus 3 squared. And then I just need to combine this stuff that's on the outside to go outside my brackets. So a negative 9 plus 8 is going to be a minus 1. So we can say our vertex is at negative 3, negative 1. We're going to look at one last example, but we're going to go through the steps for completing the squares because there are quite a few, and then you can refer to those as you practice this process. So these are the steps for completing the square when a equals 1. Notice right now in standard form, the only ones we've looked at are ones where a equals 1. In the next lesson, we'll take a look at what if a is something other than 1. So our first step in completing the square is we're going to divide the middle term by 2 and square it. Sometimes to remember this process, we say we're going to half it, cut it in half, and we're going to square it. Okay, so if I was going to do that, my middle term is 8. So I'm going to take 8, I'm going to divide it in half, and I'm going to square that value. So 8 divided by 2 is 4, and 4 squared is 16. Okay, so that's step 1. Step 2 is you're going to write both the positive and negative version of the squared value into the equation. So into my equation, after those first 2 terms, we're going to write a plus 16 and we're going to write a minus 16 plus 25. Okay, and then we know we're going to group those first 3 together because we've created that perfect square trinomial. And those second 2 will be combined outside our factored version. So we'll factor the first 3 terms. It's a perfect square trinomial. So the square root of x squared is x, the square root of 16 is 4, and we bring down whatever sign was on our middle term and raise all of that to a power of 2. Okay, and then negative 16 plus 25 is going to be a positive 9. So now we've gotten it into vertex form, and we can say, therefore, the vertex is 4, 9. Okay, we'll continue practicing this process in your homework and in the note for tomorrow. That's all for your notes for today. Hi everyone, today we're going to look at Unit 5, Lesson 5, Completing the Square, Part 1. So in our last unit, we looked at how we could go between the different forms of a quadratic, and the one that we said we were going to cover in this unit is that completing the square. So we're going to take a look at that because right now, as of last unit, we learned how to go from standard form to factored form and then to vertex form. So we were kind of taking the long way around, but now we're going to see what's that shortcut that gets us right to vertex forms and standard